So hello everyone, welcome to the session guys. So हमें डिस्कस करना है आज साउंड वेव्स फॉर AIATC, राइट. साउंड वेव्स में आप देखोगे क्वेश्चंस बनते हैं, राइट. तीन तरह के साउंड वेव्स होते हैं, हम सारी चीज़ डिस्कस करेंगे. तो साउंड वेव्स में क्वेश्चन बनते हैं, तो आप लोग इसको बहुत ध्यान से देखना. मैं जो क्वेश्चन कराऊंगा पहले तो ये लेक्चर में जो मैं पढ़ाने वाला हूँ उस थ्योरी को ठीक से पढ़ना, और उसके बाद जो है आप उसका नोट्स बनाना, और क्वेश्चन वगैरह आपको जो मिले वो क्वेश्चंस भी लगाना. और अपन लोग एक काम ये करेंगे कि इस लेक्चर के बाद में ना, अगर जैसे रिवीजन आप शॉर्ट नोट्स बनाओगे, मैं रिवीजन का एक क्लासेस लूँगा, तो आप इसको पहले लेक्चर लो. लेक्चर लेने के बाद आप जो भी बुक है उसको रीड करो, राइट. बुक रीडिंग करो, और उसके बाद आप जो है शॉर्ट नोट्स बनाओ. देन इट विल बी बहुत अच्छा हो जाएगा आपके लिए. चलो अपन लोग आगे बढ़ते हैं और एक काम करते हैं, इसको पढ़ते हैं ध्यान से कि व्हाट इज साउंड वेव्स, राइट. तो देखो ध्यान से समझो, साउंड वेव बेसिकली वही होती है. साउंड वेव्स इज द मोस्ट कॉमन वेव इन द वर्ल्ड, राइट. जो कि आप बोलते हो, अगर साउंड वेव्स ना हो तो यहाँ से वहाँ तक कैसे जाएगा, है ना. साउंड वेव्स की वजह से ही आपको एक दूसरे की आवाज़ सुनाई देती है. अब देखो ध्यान से, अपन लोग बोले कि साउंड वेव में ट्रेवल क्या करता है, साउंड वेव कैसे जाती है. और साउंड वेव क्या एस्ट्रोनॉट्स भी बोल पाते हैं? बिल्कुल नहीं. एस्ट्रोनॉट्स जो है आपस में अगर जाके मून पे या फिर ऐसी जगह जहाँ पे वैक्यूम नहीं है, जहाँ पे एटमॉस्फेयर नहीं है, वहाँ पे बोलेंगे तो उनकी आवाज़ जो है नहीं सुनाई देती एक दूसरे को, तो उसके लिए वो आर्टिफिशियल एटमॉस्फेयर क्रिएट करते हैं. सो एस्ट्रोनॉट्स वगैरह अपने स्पेसशिप में, राइट. तो मतलब ये है कि साउंड वेव नीड मीडियम, दैट्स व्हाई इट इज अ नॉन मैकेनिकल वेव, राइट. इट इज अ नॉन मैकेनिकल वेव. Let us try to understand. It is non-mechanical wave, right. Non-mechanical wave, and we have already understood that it is a longitudinal wave. Longi Longitudinal waves, right. Longitudinal waves. Let us try to understand non-mechanical wave and longitudinal wave. Longitudinal means it will be flowing in the form of compression and rarefaction. So what is it, the question arises कि what flows in the form of compression rarefaction? The answer is density and pressure, right. When you speak, the in the medium the density and pressure changes with respect to like this, right. So like this, the motion is like this. Therefore in the atmosphere there is some compression, there is some rarefaction, there is some compression, there is some rarefaction, there is some compression, there is rarefaction. So by this way, the inner density and pressure, density and, let me write here, density and pressure flows. Okay, density and pressure flows, and then your sound wave is by this sound wave propagates. Okay, so this is a non-mechanical wave and longitudinal waves. Now your sound wave is of two types. First is infrasonic waves, right. Second is audible, which we can listen, right. Audible range. And number third is ultrasonic, है ना. Ultrasound you can say, infrasound, ultrasound, या ultrasonic, right. Ultrasonic. So what happens, infrasonic is detected by thermal detectors. Thermal detectors. Audible range, best you can detect by human ears, right. Human ears are the best device to detect the audible range, human ears. Ultrasonic is detected by piezoelectric detector. Yeah, this is detected by piezoelectric detectors, right. Piezoelectric detectors. So this is your sound waves. Okay, let us move ahead. Now the important thing is, what is the frequency? So frequency of infrasound waves is less than 20 hertz, very small frequencies. Audible range, you all know, 20 hertz to 20 kilohertz, 20 kilohertz, and ultrasound wave frequency is greater than 20 kilohertz. Okay, this is the type of sound waves which we know. Now you have known the basic definition, basic properties of the sound waves. Now the important thing is to understand ki what is the speed of sound wave, right? What is the speed of sound waves? Speed of sound waves. Number one. Number one. Or number one is just let us write it normally. So you know that medium is elastic, right? Medium is elastic. That's why some compression and rarefaction is formed. So we all can say that speed depends on two things: elasticity and density of the medium. Where speed of sound is equal to under root E upon rho, where E is the elasticity. E is the elasticity, rho is the density of medium of medium. Okay, this is the question. So now we will be saying V is equal to under root E by rho. This is the elasticity and density of the medium. We all know that density of solid is greater than density of liquid, right? Is greater than density of gas. And also elasticity of solid is greater than elasticity of liquid, which is obviously very greater than elasticity of gas. So if you think like in the terms of density only, then you may say that the greater the density, lower will be the speed. Well, according to this, the speed in the sound, speed of sound wave in the solid should be less. But speed of solid, elasticity of solid is too much. So therefore, when you calculate E by rho for solid, so that is greater than E by rho of liquid, and that is greater than for E upon E by rho for gas. So therefore you can say that speed of wave in solid is greater than speed of wave in liquid is greater than speed of wave in gas. This is very important thing which you should remember, right? The very important thing is till now we are considering that the Newton said Newton said when Newton said कि when compression and rarefaction is forming, when compression and rarefaction is formed, then the process is isothermal. Then the process is, I'll write simply like this, then the process is isothermal. Then the process is isothermal. Okay. So it means we are considering isothermal now, right? So we all know that in the terms of gases or in the terms of speed of sound in air, when the when it is not solid, it is matter. So we represent the elasticity constant with compressibility, right? So E will be equal to beta, which is compressibility for air, right? For air, for liquids, right? This is this one. So now see, understand. We know that in for gases, let's say, beta is equal to what? Stress upon strain. Stress upon strain. Stress upon strain. Okay. And what is stress? Force per unit area. Therefore, it will be, you can say, simple delta P. Upon strain is delta V upon And because when you increase pressure, the volume gets reduced, and when you decrease pressure, volume gets increased, so there will be a negative gradient sign will be involved here. So we can say it is that will be minus, it will be minus delta P into V upon delta V. Okay, let us see. So now this is beta. Okay, and the process is isothermal. The process is isothermal. So we can say in isothermal process, we all know that PV is equal to gas constant is PV is equal to nRT. So PV is constant, right? PV is constant. What does it mean? Let's say this is equal to K. Let's differentiate both sides. So it will become P delta V plus V delta P, right? Partially differentiation is equal to 0. So it will become what? P delta V minus V delta P, and P delta V, sorry, we can simply say that P is equal to minus V delta P upon delta V. So if you see, this is same as this one. So can we say that when we say beta isothermal, it will be equal to pressure? These all things are important, right? Beta isothermal is equal to pressure. आया बात समझ में? बीटा आइसोथर्मल इज इक्वल टू प्रेशर, राइट? बीटा आइसोथर्मल की वैल्यू प्रेशर के बराबर होगा. एंड इफ इट इज इक्वल, then what will happen? See, we can simply say now, we can simply say that velocity of gas, velocity of sound in gas under root beta by rho, and beta by rho we can simply say beta isothermal will be what? That will be under root P upon rho, right? It will be equal to P upon rho, right? And you all know that PV is equal to nRT. Right? PV is equal to nRT, and volume is what? Mass upon density. So P mass upon density is equal to nRT. Correct? Now if we say P upon rho will be what? P upon rho will be, let us calculate from here, nRT upon m. nRT upon m. So can we say that if we are taking n is equal to 1, right, that is gas to be 1 mole, then it will become what? RT upon m, and the speed of sound will become V is equal to under root RT upon m. Okay, RT upon rho. Now you know all the things, right? Gas ka mass, molecular mass, you know, R, you know, temperature, you know. If you put all these values, it comes out to be, ध्यान समझना, it comes out to be 280 meter per second. If you put all the values, like R is equal to 8.314 है ना, T is equal to 273 Kelvin particular some. At room temperature you can take T equal to 300 degree centigrade. Molecular mass of, you can take any gas and put the value, then it will be coming around 280 meter per second. But with the observation, it has been observed that velocity of sound, right, ध्यान समझना, velocity of sound experimentally, right, through experiments we got something around 332 meter per second. With the formula we got 280 meter per second, but with the experiments we got 332 meter per second. What does it mean? It means there is some flaw in the formula. It means there is some flaw in the formula. What does it mean? Who corrected it? The very famous mathematician Laplace. Laplace came to the picture and Laplace corrected it. Laplace said, whatever you are doing, my friend, everything is correct. Only one thing you need to modify. And what is that? Newton had said that the compression and rarefaction formation is isothermal, but Laplace said no, my dear friend, the compression and rarefaction formation is adiabatic. So here he corrected only the Laplace said compression and rarefaction formation is adiabatic. In adiabatic process, what happens? In adiabatic process, the heat transferred is zero. That is delta Q is equal to zero. And we all know that in the terms of in adiabatic PV to the power gamma is equal to constant. PV to the power gamma is equal to constant, right? This is equal to constant. Now in the same formula, when you will calculate everything, right? Like you will calculate beta is equal to minus delta P upon delta V upon V, and when you will differentiate it, let me do it for you. So how will we be getting? Let's say PV to the power gamma is equal to constant. So what will say? Differentiate it. P into gamma differentiation will be gamma into V to the power gamma minus 1 into delta V plus V to the power gamma delta P is constant, differentiation is 0. So it will become what? Let us multiply with or you can simply say it will be, see, gamma P V to the power gamma minus 1, we can write V to the power gamma upon V into delta V plus V to the power gamma into delta P equal to 0. Now if you take V to the power gamma and shift it to the direction, so V to the power gamma you can take common, you will get gamma P delta V upon V plus delta P equal to 0. So this one will be shifted to this direction, you will be get gamma P delta V upon V is equal to minus delta P. So gamma P is equal to minus delta P into V upon delta V, right? So this is equal to what? This minus delta P V into upon delta V. So in the same way, see here what you got, the same value had the same value was equal to P, but here the same value is equal to gamma P, right? Here the same value is gamma P. So speed of sound which will come out to be, we will get V speed of sound is equal to under root uh, it was what? It was equal to P by rho, na? So it will become gamma P upon rho, right? Gamma. So this formula was wrong. This formula became wrong, right? So we got gamma P upon rho. Gamma P upon rho means the same way you will calculate, you will get under root gamma RT by M. So we can simply say it will become velocity of sound is adiabatic, so it will become what? Gamma RT upon M. And when you calculated with respect to this formula, you got the correct form of speed of sound, and that's why this formula is acceptable. So Laplace corrected the formula, Newton introduced the formula. Newton introduced the formula, Laplace corrected the formula. This is very, very important thing you should note, because in the question, the formula, question comes somewhat theoretically, like it will simply ask who introduced the formula of velocity of sound? Newton. Who corrected it? Laplace. Who finally uh, derived the formula for sound? Laplace, right? So it will be this one. And gamma depends upon type of nature of gases. So gamma will be what is equal to 1 plus 2 by F, where F is, small f is degree of freedom. We'll just simply write it, degree of freedom, right? So which value is 3, right? 3 for monoatomic gases, 3 for monoatomic gases, Monatomic gases, like helium, neon, is this type of gases. 5 for diatomic gases. Diatomic gas means hydrogen, nitrogen, oxygen, etc. And 6 for polyatomic gases, like methane, CH4, and H2O, etc. This one will be formula for this one. So what happens now? We can say R की value, R is equal to 8.314. The unit I don't remember, you should remember. You don't worry कि सर आपने याद नहीं किया मैं क्यों करूँ. So this one. चल. So this is the formula we got for this one, right? And one very important thing, root mean square speed, right? मतलब speed of molecules in any medium, that is VRMS. This formula is equal to under root 3RT upon M. Just remember these things. This is a very important thing, right? Root mean square speed of any molecules in the any medium is under root 3RT upon M. Speed of sound is gamma RT by M, right? Sure. So this is the very important thing. Now next concept is factors affecting the wave speed. This is very important thing. Let us try to understand. Right. So if you see the formula, we can simply say that it's equal to under root gamma RT upon M. Right. Gamma RT upon M, which was equal to under root E by rho. Yeah, you can say beta upon rho. Right, you got it equal to gamma P by rho, right? So these are formula. So in the final formula, this comes out to be this one, right? You have to remember this formula for the factors affecting. So you can simply say first thing is speed of sound is directly proportional to root temperature, right? This is directly proportional to temperature. It means if you will calculate it, you will get V. I'm just writing Vt is equal to V0 plus 0.61 T. What does it mean? It means, or you can write it like this way. Speed of sound at another temperature T2 is equal to speed of sound at temperature T1 plus 0.61 into delta T, matlab T2 minus T1. So when you increase temperature by 1 degree, then the speed increases by 0.61 meter per second, right? So if you will increase the temperature, the speed of sound will increase. Correct. Second thing is pressure. Now you may understand, sir, what is the effect of pressure? The interesting thing is there is no effect of pressure on the speed of sound, right? No effect, because gamma P by rho has been finally converted to this one, right? Second thing is rho. So obviously you can say humidity of the atmosphere. That so you can say that in the time of, I'll tell you, uh, the density of dry air is greater than density of moist air. Moisture wala air density is less. So if density is less, the speed of sound will be more. So you can say during the rainy season the speed is more. When it is a moisture season, the speed is more, right? So you can say speed of sound in dry air will be less than will the speed of sound in moist air, right? So this is the very important thing which you have to understand about the sound, right? About the sound waves. So now the remaining thing is beats and Doppler effect in the wave, which I will cover very soon, right? And after that we will start the optics portion. So it is very important portion. Don't miss this class. And guys, I tried to keep this class in English. So if you liked it and if you need any suggestion, if you want to give any suggestion, please, you're most welcome. Do comment in the comment section and appreciate if you love it, right? I don't say that appreciate and like everything, but yes, if you like it, if you love the teaching, if you love the content, if you love the teaching style, if you love the teaching pedagogy and methodology, then you should comment below, because I don't have any subscribers, right? Sorry, I don't have very a large number of subscribers. I just want to help you guys, right? This is my hobby. Teaching is my hobby. I can't leave teaching, right? Wherever I'll be teaching. But when you guys support it, so we simply get motivated, right? So thank you, and see you in the next video of beats and Doppler effect. Please help me to get 1000 na, at least to आज soon. चलो bye bye guys. Anyway, I'll be uploading the lecture whether you give me 1000 or not. चलो bye bye. 1000 subscribers, not rupees, right? चलो okay, bye bye.